Consider this simple question that more than 50% of Harvard students got wrong. A bat and a ball costs $1.10. The bat costs $1 more than the ball. So, how much does the ball cost? 10 cents, right? Well, that may be your initial instinct, but the correct answer is 5 cents. This trick question is the first one that appears on the cognitive reflection test, a simple test with only 3 questions. Professor Shane Frederick from Yale University designed the measure to test how well people could suppress their initial reaction in favor of a more thought-out answer. Now, he gave this test to about 3,500 people, most of them being college students. Yet, in the end, he found that only 17% could get all 3 correct. This is concerning because other researchers have found that the worse you perform on this test, the more prone you are to cognitive biases. Furthermore, your score on this test also correlates with your SAT scores. So, for only 3 questions, it's quite a revealing measure. Yet, there's a surprisingly simple way to improve your performance on this test. If you present the questions in a harder to read font, this time, 65% of people get all 3 questions correct. It's a staggering improvement. What's more surprising is that this strange effect of font shows up in a variety of other circumstances. For example, fonts that are harder to read also improve memory and learning. In one public school in Ohio, researchers asked teachers to change the font used in their worksheets and PowerPoint presentations. Instead of the usual Times New Roman or Arial, students would now have to read fonts like Monotype Cursiva. Now, you'd think that this would actually hinder the learning process, right? Yet, compared to classes with the normal font, these students scored significantly higher in their later tests.
Inspired by this YouTube video, we decided to recreate this experiment and see if changing the font really affected performance on the cognitive reflection test.
When collecting data, we decided to survey math classes in order to get a sample representative of the Torrey Pines population. Since almost all students take math classes and we could easily cover all levels of academic performance, we found this to be optimal.
We surveyed 7 different math classes: Math Analysis, Integrated Math, Algebra 2 Prep, Statistics Prep, Algebra 2 Trig Honors, AP Calc AB, and SDSU Linear Algebra.
We randomly gave half of the class the slip with the easy-to-read font, and we gave the other half of the class the slip with the hard-to-read font. You can see examples of each type of slip and font in the photos in the slide. Our experiment is considered to have a blocking design because we broke participants into blocks based on math level, and the variability within blocks is less than the variability between different blocks themselves.
Randomization was achieved by randomly assigning half of the participants in each block to each of the differing font types. By going to each class and passing out slips rather than having people participate on an online survey, we eliminated voluntary response bias.
However, we did have some non-response bias as a few students refused to participate in the survey or did not fully fill out the slip. Since we are assuming these students would have gotten lower scores on the test, this might have slightly skewed our distribution towards higher scores.
There was some undercoverage bias as we did not go to every type of math class and not all grades were equally represented.
On our survey slips, we requested that students fill out their math class, gender, and grade to make sure that there were no confounding variables.
With a large sample size of 188 students, we are able to minimize variability.
Here's an analysis of our data for the slips with easy-to-read font. As you can see, most students got a score of 0 out of 3, and the average score was 1.38.
Now here's our analysis for the hard-to-read font. Similarly, most students got 0 out of 3 correct. On average, the score was 1.29.
Contrary to previous research studies in which students performed better with the hard-to-read font, Torrey Pines students actually performed better with the easy-to-read font. We must now see if our data is statistically significant in order to determine whether or not there's an association between font reading difficulty and performance on the cognitive reflection test.
Since we didn't have a wide range of scores, we considered our data categorical.
Furthermore, since we were testing to see if there was an association between CRT scores and font readability, we used a chi-square test for association/independence.
Our null hypothesis was that there is no association between font readability and CRT score, while our alternative hypothesis was that there is an association between them.
From our observed data, we were able to calculate expected values by multiplying the row total by the column total and dividing by the overall total for each observed value.
The conditions for the chi-square test were met as all the expected values were greater than 5.
We calculated the chi-square value by summing the observed minus expected square over expected value for each of the 8 data points, which resulted in a value of 0.7746.
The degree of freedom was calculated by taking the number of rows minus 1 times the number of columns minus 1, which resulted in a value of 3.
In looking at the chi-square table, our p-value was greater than 0.25, and in doing the calculations with a calculator, we found a true p-value of 0.86.
Since our p-value is so large and far greater than any standard significance level, we cannot reject the null hypothesis and fail to accept the alternative hypothesis.
This means there is no association between the font reading difficulty level and the CRT score of TPHS math students.
Although we didn't give the survey to all TPHS math students, we are able to generalize because we conducted a randomized experiment that utilized the blocking design.
If we reconducted the experiment, we would try visiting an even larger range of math levels and enforce the no-talking policy even more to ensure that all students answered independently from one another.
In the original CRT research, Shane Frederick was able to show that women performed worse than men and that the difference was statistically significant.
In our data, males also performed better than females. However, this difference did not seem to be as significant.
In order to see if gender actually played a role, we conducted another chi-square test for association.
Our null hypothesis is that there is no association between gender and CRT score, whereas our alternate hypothesis is that there is an association between gender and CRT score.
We once again verified that all expected values were greater than 5. Our calculation showed that chi-squared equaled 1.88 with a degree of freedom of 3 and a p-value of 0.598.
Once again, our p-value was far larger than any standard significance level, and we could not reject the null hypothesis. This means that there was no association between gender and the cognitive reflection test scores of TPHS math students.
Here is Shane Frederick's data when he conducted the CRT test at a number of different universities.
We compared Shane Frederick's data on MIT, Princeton, CMU, Harvard, and UMICHIGAN to the data on Torrey Pines that we collected through our experiment. Torrey Pines math students performed better than students at UMICHIGAN, but worse than students at Harvard and the other 3 universities.
However, we wanted to see if Torrey Pines' performance was statistically significant in comparison with UMICHIGAN. We did so by performing a third chi-square test for association.
This time, our null hypothesis was that there is no association between school name and CRT score, and our alternate hypothesis was that there was an association between school and CRT score.
We got a chi-square of 31.41 with 3 degrees of freedom, which resulted in a p-value of 7 times 10 to the negative 7.
This extremely small p-value means that we can reject the null hypothesis even at a significance level of 0.5%. Therefore, there is an association between school name and CRT score, meaning that TPHS students did not achieve a higher mean score solely by chance and did actually perform better than UMICHIGAN students.
We thought it would be interesting if we compared Mrs. Brown's linear algebra class to other universities, since it is the highest level of math offered at Torrey Pines.
The highest scorer among the colleges was MIT with an average score of 2.18. However, the linear algebra class performed significantly better with an average score of 2.48.
However, since not all the expected values were greater than 5, we did not meet the conditions for the chi-square test.
Unfortunately, this meant that we could not prove the significance of our observation.